we're looking at case 2 of the chain rule, whereby we have z as a function of two variables, x, y. And each of those variables, each of them are also functions of s and t. So in that case now, we can have the following equation, del z, del, so we are going to do it del z with what? Respect to this, then del x, and that will be equal to, very simple, that will be equal to del f, del x times, where you stop here, that will be beginning here, del x, all over what you have here, del x, then plus del f over del y times whatever you have here, that will start here, del y over what you have here, del x. Then the next one, del z over what? The next function, del t, will be equal to del f, del x times del x times del t plus this. So these are the two equations that that is very, very important. For your equation for x, you're going to get we're going to do the partial differential respect to x and also respect to t. Same thing also for y. You're going to get the partial differential respect to x, respect to t. We have this question: find del z del x and del z del t for z equal to exponential to power 2r sine 3 theta. R is equal to xt minus t squared, and theta is equal to square root x squared plus t. So the first thing to do is to analyze the given equations. Z is a functions of r and theta. In this case now, we can get del f, del r, okay? And we can also get what? Del f, del theta. So let's get that. Differentiate this in subscripting notation, that z, there have spot your r function, y theta will be kept as a constant. In that case now, I'm only differentiating this one. That's the only place I have r, okay? And that will be equal to, this will give me e to power 2r times what? Times 2. If you differentiate this one, that will be 2. And then sine what? Sine 3. Can we also get del z, del theta, which is this? Differentiate also this one, respect to theta. In that case now, r will be kept as a constant. And that will give us what? We're going to keep this one as a constant, and we're going to differentiate this one. And this one is a chain rule. It involves chain rule. So derivative of sine is cos of that inner function. And then times derivative of the inner function, 3 theta. Okay? And that will be what? Times 3. That's the partial derivative respect to theta. Then we want to go to this one. We want to go to the other function, the r. R is a function of two variables. So I'm going to differentiate that respect to x, and that will be del r del x. Okay, and that will give me t, because you only differentiate the x while you keep your t constants. Then let's do the same thing also, del r del t. Differentiate this one also respect to t. That means you are keeping your x constant, you are only differentiating t. And in that case, that will give us 4 times. You have this. And then minus what? Minus 2t. So I'm through with the r function. So I'm going to theta now. We can differentiate theta respect to x. Okay? But before we do that, we need to do the algebra of this. Theta can be written as what? X squared plus t squared to power half. And this will be equal to what? The power will come to the front, then the expression s squared plus that t squared, then that power minus 1, that's minus half. And don't forget, this is a chain rule times what? The derivative of the what? Of the base to 2x. So this one, these two, and these two cancel. Have this one, theta subscript x is the same as what? Del theta del x. So this one is giving me this. Can we also get del theta the t? Differentiate that with respect to t is going to give you half. Come to the front, f squared plus t squared. The power minus 1, that's minus half, times the derivative of the composite function of the base times 2t. So these two we cancel. So we have t over square root of what? S squared plus t squared. We've gotten all the necessary parameters. In the first case, we need del z del x. That's what the question instructed us. We're being told to find what? Del z del x. That's the first case. So, and that will be equal to my del f del r is also the same thing as what? It's also the same thing as del f del r. So let's begin to make substitution to that place. Del f del r is the same thing as z subscript r, and this one also del z del theta. It's also the same thing as what? Del f del theta. They are the same. They are the same thing. I've said it at the beginning of chain rule that if you have z equal to this function, then you can write z del x is the same thing as del f. Okay, so let's do our substitutions. Respect to how we have the value here, okay, which is 2, and then del r del x, del r del x, we have the value here as what? Plus del f del theta, which is same thing as what? Del z del theta, which is this. Del theta del x, that's the value here. We have it here. Here, del f del r is this one. This is 2r, so not r, that's 2r. Then the next thing to do now is to this variable is having r, theta, and t. We want to ensure that it conforms to the given, to change it to just to be r and theta, but it's not a must. Have to begin to substitute your r. We have a value for that, so which is the r is this, and then sine. Theta also has a value which is this, okay, and then times what? Times t. Then plus here also in cos 3. Theta is what? Theta is this times over what? Over this. So that's that on the del z del x. Okay, then it was a functions of 3 variables. We have succeeded to make it what? 2 variable. Okay, from here we have t, we have theta, we have r. But finally we have succeeded to make it what? 2 variable according to the what? According to the r and theta. Okay, so we're going to have del z t. Okay, and don't forget this z is a function of what? The functions of r and theta. So in this case now we're going to have partial differential respect to r. Then we also need partial differential, okay, respect to theta. So which is equal to what? Del f del r times del r over del t. Okay, then plus del f del theta times del theta over del t. This is very simple. Don't forget, r also is a function of 2 variables, which is x and t. Okay, so and also theta is also functions of what? X and t. So in that case now, once you do the partial differential of the first one here, it's going to be what you have here. We'll start here times, we've done this one before, so times what? Over So that's what we have. Can we begin to do the imputation? Del F, del X is the same thing as what? Del Z, del R. This one also is also the same thing as well. Del Z subscript theta. This is also the same thing as well. Z subscript what? Subscript R. So, and that's equal to what? The R, the T is this. That's X minus 2T, then plus del F. Del theta is the same thing as what? Z subscript what? Subscript Z theta. So which we have a value for that, which is this one, theta del T. We have the value here. This one, that's the theta, the T, which is the one we have here, which is times T over this. So then the next thing to do now is to, if we check this variable, we have our answer is a function of R, theta, and T. So what we can do, we can make it to be function of two variables. So just go back to your questions, and this will be equal to R is what? We have the expression for R, which is what? St minus t squared sine theta is this, then x minus 2t, then plus, do the same thing also here, 3e, my R has an expression which is st minus t squared, and then cos 3 theta. Theta is what? Times this t on top here, can come here, you can put the t here, over. Yeah, the next video is going to be a tree diagram for chain rule. We are still on chain rule. Okay, I want to solve as many questions as possible on chain rules for multiple variables. Okay, please, there's a watermarks on the video. Quickly smash it now and subscribe so that as I upload, you get notified of the latest updates from this channel. Don't stop there. Click on the like button and begin to type your comments. We promise to respond to your question as soon as possible. Finally, share the links of this video on all your social media platforms. Thank you for doing that.